We are group 1 and we did our project on free fall. I'm Maya.
I'm Stephanie.
I'm Michaela.
And I'm Magdalena. Okay, so a general overview of the project. We did 3 trials. On the first trial, we dropped a pumpkin that stayed the same, the weight stayed consistent throughout the entire trials, and that was 28 grams for the pumpkin. And the flat sheet of paper was 3 grams. The second trial, we dropped the pumpkin in a single crumpled sheet of paper. The pumpkin weight stayed consistent, and then the single crumpled sheet of paper was about 3 grams. For the third trial, we dropped the pumpkin and a bunch of crumpled paper that weighed 26 grams, so 2 grams less than the pumpkin. We did this because we wanted to have different masses for the paper, so to keep it less than the mass of the pumpkin so that we could compare it to the time of the pumpkin touching the floor. Why we wanted to do the project, we wanted to show how the air resistance is present. When the air resistance is present, 2 objects will not land at the same time. And then just to clarify, the free fall law states that in the absence of air resistance, all bodies fall with the same acceleration independent of their mass.
Okay, so as we studied in class lecture, we learned that Aristotle stated that objects fall with velocity proportional to their weights. However, Galileo stated and concluded that motion under the action of gravity and acceleration. Therefore, the magnitude of the uniform acceleration in free fall is dependent of the weight of the object. The constant acceleration is defined as 9.8 meters per second squared. So it is said that if an object has equal acceleration during free fall, the 2 objects side to side, they should reach ground at the same time. This is true if air resistance is not present. Here in the first trial, we have 2 objects with different masses, a pumpkin stress ball of 28 grams and a straight 8.5 times 11 inches of sheet of paper that weighed 3 grams. The total amount of time that it took for both objects to reach the ground was 3 seconds. The pumpkin reached the ground in 1 second and the sheet of paper was 3 seconds. Therefore, because air resistance was present, both objects did not land at the ground at the same time.
Next, we crumpled the one piece of paper into a ball to see if it would change the amount of time to reach the ground. As we have said, in the first trial, it only took 3 seconds for the flat piece of paper to reach the ground, while it only took the pumpkin 1 second. Once we crumpled the paper, the pumpkin still only took 1 second to reach the ground, while the piece of paper took substantially less time than before and only took 1.5 seconds to reach the ground. This is probably because the ball of paper has significantly less surface area, meaning that there would be less air resistance.
So in the third trial, the pumpkin stayed the same and there was more paper added to the crumpled piece of paper. And it took only about half a second less to drop than the pumpkin did. And this is most likely because the masses were a lot closer together and the piece of paper had less surface area for air resistance to happen. And in a closed system, these 2 objects would have fallen at the same rate. So the objects were dropped from the same height and so that they would fall at the same rate. And everything on the Earth when in free fall experiences the acceleration of 9.8 meters per second, and none of the objects were able to reach their terminal velocity, which is the constant speed, and an acceleration of 0. So all the objects have the same acceleration when in free fall of 9.8 meters per second. The 3 videos show different acceleration because it is not a closed system and there was some air resistance for the masses. And a source of error that we had was that it was windy, and so it definitely affected how the paper dropped.